So our last of the three types of transformations are the idea of stretches and shrinks, which is caused by applying the operation multiplication to the function in one of two places. Keep an eye out for the difference again between inside and outside. Remember that inside typically has something to do with opposite. Right? Whenever something occurs on the inside of the function, the impact on the graph is opposite what we might expect it to be. So for example, when I multiply a 3 times the x on the inside of the function, it causes the x-coordinates of all points to shrink by a factor of 3, even though we're multiplying by the number 3. And if I multiply by 1/2 on the inside, it causes the x-coordinates of all points to stretch by a factor of 2. And it's just the x-coordinates. The y's are fixed. We'll see what that looks like in a second numerically. And then on the outside, right, we expect that outside is the same, and again, it's vertical. Right? If we think about words, same and vertical. When we multiply 4 on the outside, we cause the heights of all points to stretch by a factor of 4. When we multiply by 1/3 on the outside, we cause the heights of all points to shrink by a factor of 1/3. Right? So in that case, things happen in the direction we would expect. Let's take a look at what would happen numerically under a particular type of transformation. So if I want to look at the function absolute value of 2x, right, given what we just looked at, that would be a shrink horizontally of a factor of 2. The first xy chart you see over here is what would be the regular xy chart for y equals absolute value of x. And so you can track where, right, the heights go. Remember, the heights are supposed to stay the same. So here are the heights of y equals absolute value of x in the new function y equals absolute value of 2x. Take a look at what their corresponding heights are. Before, 2 went with minus 2. Now 2 goes with minus 1. 1 goes with minus 1/2. 0 stays where it is because 0 is not affected by multiplication. 1 goes with 1/2, and 2 goes with 1. So leaving the y's the same, taking that same set of y's, the x's they correspond with are each half as much as the x in the original function y equals absolute value of x. Then when we move on to the graph itself, we can see the way that absolute value of 2x, if we simply look at it from an x perspective, what happens to the points, the heights? It's shrunk inwards on us. Right? Here's the 1/2 1, 1, 2, 2, 4, right? And in green you can see the original graph. Everything has moved in. It also impacts, if we want to do this without an xy chart, what that generating rule is for the function. When we were talking about absolute value of x, the generating rule was go 1 unit right and 1 unit up from the home base. For this new function, absolute value of 2x, it's go 1/2 unit right, 1 unit up. Okay. Because we're shrinking by 1/2, so as we generate points, for every half unit we go over to the right, we want to go 1 unit up. That results on a different looking graph. It's important that we have these points in here so it's clear to anyone, right, in a single graph where I'm not drawing both absolute value of x and absolute value of 2x. Right? So it's clear what the new function looks like and that we understand the stretch or the shrink that's in play. Let's look at one more example. So if I have y equals 1/3 the absolute value of x, that's a vertical shrink by a factor of 1/3. And that means that the heights are changing. So the new rule after I find the home base would be go 1 unit to the right and go 1/3 units up because I'm changing the heights. The height should be lower each time. The home base hasn't gone anywhere. The home base is still at 0, 0. Now I go over 1 unit to 1 and I go up to 1/3. Go over 1 more unit to 2, I go up to 2/3. When I go over 1 more unit to 3, I go up to 3. And I could continue that over up 1 to the right, and then I could turn it over to the left and go over 1 unit to the left, up 1/3, over another unit, up 1/3. Continue to sketch out the possible points and connect them. And what happens when we connect them is we get this flattened version of the absolute value. This is y equals 1/3 the absolute value of x, which visually makes sense. The height should be flattening down on us. So what you really want to do as you do these problems in the homework is think about, how do I generate the function around the home base? Right? If the x's have changed, then it's how many units over should I go now? If the y's have changed, it's how many units up should I go now? Right? If you can write that new rule, you should be able to handle the problems that are there.